So this is the solutions to homework 2. There are 3 problems, that's all, on page 83. And in the first problem, we're given the state diagram of 2 different machines, M1 and M2, and we have to write the formal descriptions, the 5-tuple that describes the machines. So this is the machine M1, this is the machine M2. Double circles around this state, so that's the start, arrow coming into Q1, that's the start state. Arrow coming into Q1 and M2, that's the start state. The except states are the states with the double arrows, double circles. Q2 for the first machine, Q1 for the second machine. If you input AABB, what is the path you trace in the machine? Q1, A sends you to Q2, another A sends you to Q3, B sends you to Q1, and another B sends you to Q1. So you end up in Q1. That is not the accept state. The accept state is Q2. So does this input get accepted? No. And if you put in the empty string, that means there's nowhere you start at Q1, you don't go anywhere. You end up you're still at Q1. That's not an accept state. So the answer to that is no. And the empty string is not accepted. In the machine M2, this is the start state and the accept state. If you trace out the path from the input AABB, A sends Q1 to Q1, another A sends Q1 to Q1, B sends you to Q2, another B sends you to Q4. You end up at Q4. That's not the accept state, so it's not accepted. But the empty string, you start at Q1, you don't go anywhere. That's an accept state, so the empty string is accepted. If you want the formal description of these 2 machines, for the first machine, there are 3 states, Q1, Q2, Q3. The 2 symbols, 2 letters coming out of each state. The alphabet is just A and B. To compute the transition function, you just have to write this little table or matrix. If you're in state Q1, A sends you to Q2 and B sends you to Q1. In state Q2, A and B both send you to Q3. In state Q3, A sends you to Q2 and B sends you to Q1. The start state is Q1 and the set of accept states is just Q2. For the second machine, there are 4 states, Q1, Q2, Q3, and Q4. The alphabet is A and B. The transition function, see, if you're in state Q1, A sends you to Q1 and B sends you to Q2. In state Q2, A sends you to Q3 and B sends you to Q4. In state Q3, A sends you to Q2 and B sends you to Q1. And in state Q4, A sends you to Q3 and B keeps you at Q4, in state Q4. The start state is Q1, the accept state is also Q1. So this is the formal description of these states. And in problem 3, you have a discrete finite automaton, a DFAM. There are 5 states. The alphabet is up, U and D, like up and down. The transition function delta is given by this table. Q3 is the start state, and Q3 is also the accept state. So if you draw the diagram you have 5 states, Q1, Q2, Q3, Q4, Q5. Q3 is the start state, so there's an arrow coming into Q3. Q3 is the only accept state, so there's a double circle around Q3. And from this table tells you how to draw the arrows. So from Q1, U goes to Q1, and D sends you to Q2. In Q2, U sends you back to U1, and D sends you to Q3. In Q3, U sends you back to Q2, and D sends you to Q4. In Q4, U sends you back to Q3, and D sends you to Q5. And in Q5, U sends you back to Q4, and D keeps you in the same state, Q5. So that's the state diagram. And that is all there is to the homework. But it's important to learn the words. That's really the key thing here, to understand the words and how the words and the pictures connect.